Yeah, all right, thanks. Hi everyone. Good evening.
Good
My
evening,
name
good evening,
is
sir.
my name is Awulabi Adenio, and I'm a junior DevOps engineer with Amoye, and I welcome you all to today's live coding session. And today will be the continuation of the live coding session for stage A. And in our last live coding session, we took an introduction to NumPy, where we where we spoke on the details of what NumPy gives to us, how we can use NumPy to create arrays, manipulate arrays, creating 2D arrays, performing mathematical operations, and we also spoke about how NumPy performs operations element-wise, in the sense that any operation you are performing to an array gets performed to each and every element that is contained in that array. So unlike lists where the list is treated as, so I just want to confirm if I can be heard.
Yeah, we can hear you.
Yes,
Yeah,
we can hear
thanks.
you. We can
Yeah, thanks. Unlike lists where the the data structure is treated as a whole, and for you to perform operations to every element in the list, you need to use an iterative process or an iterative step where you first access every element in the array before you can perform the action. Um, that's one of the benefits that arrays give to us, element-wise operation, and we also saw how extensible NumPy is, in the sense that it has been used in a lot of different libraries, which you guys will get to interface more with over time. Um, NumPy forms as a core basis of Pandas. NumPy is NumPy is a core basis of Pandas. Forms a core basis for Matplotlib. Forms a core basis for a whole lot of these um, libraries and modules that will be used a lot in your part for data science and data analytics. So today we'll be talking on one of these modules that was mentioned last week, that that NumPy is being integrated with, and all of these are provided by Python. So I believe you all can see my slides. So today is Pandas, and it's a powerful library for data manipulation and analysis, and it's an essential tool in the arsenal of any data scientist or analysts, because it offers intuitive data structures and functions for working with structured data effectively. So Pandas is one of the best modules aside NumPy that one will use, because it helps in structuring data, in the sense that you see a difference in the way NumPy arrays were printed out in our last live coding session. You saw that it just used brackets, and all of these values were put in these brackets. But Pandas extend this functionality to give us tabular formats. You can begin to see your data as a table with columns and rows, and you can start visualizing your data in a tabular format, which you can then use to perform actions. And this extends the amount of functionality you have, in the sense that you can begin to start performing actions as you would on a normal table, in any other aspects where a table can be used. um it is built on top of NumPy, just as I've stated previously. NumPy serves as one of the core libraries on which Pandas was built, and it provides high-level data structures such as series and data frame, labeled and relational data. So whether it is a tabular data, a time series, or a structured data, even if it's unstructured in a way, Pandas equips you with the tool you need to clean, transform, and analyze the data set. So for people that will be focusing a lot on data storytelling, when you want to perform analysis on pandas when you want to perform analysis on the data to try and gain insights or visualizations, or even try to just explain what the story that the data is trying to tell you, you are going to need to know how to manipulate with pandas. So you can abstractly say that Pandas is the SQL equivalent of Python, because with SQL you work with structured tabular data, and then you can provide queries to this tabular data to try and get some values, to get some rules and stuff like that from the data. So the equivalent for what the functionality that SQL gives you is basically what Panda is to Python. So with a lot of different tools that that SQL gives to you are embedded in Python, and sorry, in Pandas from Python, and even a lot more that you can use to gain data or gain particular values from the data. Okay, so let us look at some of the key features that Pandas provide to us. So one of the key features is data structures. So in Pandas, there are two primary data structures. Just like in NumPy, there's just one data structure, which is the ND array. So every NumPy array you are creating belongs to. Sorry, who is that? Can you just mute your mic so you don't disturb the class? Okay, I think the person is on mute now. Thank you. So um for every numpy array you create in
Okay.
numpy, sorry, was anybody trying to say something? Okay, I'll take that as a no. So for numpy arrays, any array you create at all is going to be contained in what you call an ND array. That's the type. I showed this last week where we put in a numpy array into the type function provided to us by Python, and you see that the only response we get from this running this action is we get that this is a type ND array. But in Pandas, we have two arrays, and we have two data types. The first is the series data type, and the other is the data frame data type. So the series data type represents a one-dimensional labeled arrays, while the data frame represents two-dimensional labeled data structured with columns of potentially different data types. So emphasis on the different data types, in the sense that in NumPy, there is no option for immutability, in the sense that everything has to be everything. So there's no more option for inhomogeneity. Everything has to be homogeneous. You have to follow some set down rules and guidelines before a numpy array can be created. However, with Pandas, it gives you more flexibility, because Pandas understand that in a real world scenario, it is possible there will be some aspects of data that you will not have access to, and you might want to work on a data set where some values are missing and some values are present. So if you are trying to follow to letter the set down rules and numpy has given, you might not be able to work with your data, because some of these values will be missing. Some key rows might be missing, some key columns, some key values in some key columns might be missing, and all of this will add up to not allow your data to follow, to be the same size and of the same length. And this can cause an issue with you working with numpy directly. But Pandas has given us this functionality where we can have different types, all of even different data types, different shape, all together in each other. So the second key feature is data manipulation. So Pandas offer a plethora of functions. The functions are just there are so many that we won't be able to go through all of them. If we use 2 3 months to just go on Pandas alone, you see a lot of different functions and functionalities that has been created for you to use with Pandas. So over time, you have to keep gaining experience. So at the time when you need to perform a particular type of step, you then research on the nature of the function that you're going to require, and then use this in whatever solution you want to create. um and these functions enable seamless data cleaning, transformation, and aggregation. So just as I said, with SQL provides a lot of functions. The web functions is used for to filter the table. We have selecting of counts. That's where you select some particular stuff. You can aggregate. So all of these functions Data cleaning, transformation, and aggregation are very, very important steps in any data analysis or data science project. And Pandas is the main Pandas is the main library that we use to perform all of these functions before moving to a model. The third key feature we're going to be talking about is handling missing data. Pandas provide robust mechanisms for handling missing data or incomplete data, and you can fill this data, drop this data, or interpolate missing values efficiently. So just as I have said, it is possible in a real world scenario when you are gathering data that data could be lost, or there might not be enough resources to gather some data in some particular aspects. But these data are required for you to perform your analysis. So Pandas offers ways for us to deal with this missing data. Based on the nature of the data, you can decide to fill the data, or if the missing data is actually small. Let's say, for example, you are working with a data set, a sample size of 1000, and out of the sample size of 1000, you have just two missing values. We can confidently say that dropping these two missing values will not change the narrative of whatever insights the other 998 samples we have is going to give to us. Therefore, in that case, it is okay to drop these values. But in a case where you have almost half of the data missing, and this is another case where we can drop the value. So in a case, let's say 90% of the data is missing, 10% of the data is not enough for you to draw valuable insights. So in that case, you might just decide to totally drop off that column, or probably look for ways to gather more data, because you cannot give confident statistical results based on a sample size that is not even up to 50%. But in a case where the missing data is suitably situated in between 70 to 80%, or 70 to 90% of the data is missing. In that case, then we can try to use information. Let's say, okay, it's a particular domain, you can use domain information, or you can just use popular techniques to fill the data in that sense, because the sample size that is missing is not, the impact it will have when you fill this data is not going to be too much to take away the actual insights that you'll be learning from the data. So one very, very key stuff in any data science project is handling missing values, and you do it a lot, because a lot of data you meet out there is never complete. There will always be a missing value somewhere that has to be dealt with. Another key function that we have is time series analysis. So Pandas excels in time series analysis, of offering specialized functionality for working with time index data, such as resampling, time zone handling, date range aggregation, and the likes. What do we call time series data? Time series data is a data that is dependent on time. It's a data set um, that takes into account the time at which that data was collected. A popular example of time series data is weather. So any data set that is trying to give the weather over a period of time is a time series data, because the data set takes into consideration the timestamp, that's the time at which this particular observation was collected at that point in time. So data sets like that are called time series data, and Pandas has a whole set of functionalities that is available for you to manipulate this time data, because originally the date and time is not, you can't particularly call it a number, and you cannot particularly call it a string. In most data sets, the dates or the time, or the date and time combined together, will most likely be represented as a string. So for you to be able to perform some analysis that will also take into, for example, trying to find the number of days that it took for a particular observation to occur, or let's say you have a weather data and you want to know the amount of days that the amount of rainfall is over a particular limit, you need to be able to work with the dates that is contained in this data set, and at first it's provided to you as string, but Pandas gives you methodologies that you can convert this to a suitable format where you can then begin to analyze. So that's basically a full brief of everything about Pandas and what it can be used to do. And this is definitely not everything, because it's a large data set that can be used for a lot of different functions. And as I stated in the last coding session, there is no way we can cover it all based on the series of lessons we are having, or even the course materials that we are being provided with. What we are just trying to do is to provide you with a very very foundational level that you can use to be able to increase your own knowledge over time as you gain more experience and working on more projects. So it takes conscious effort on your part to want to learn more of these things, so you'll be able to make researches and look for examples of real world solutions that you can solve. And in the process of doing this, you'll be able to learn more. Okay, so I'll be switching my tab now. Let me share this tab instead. So before I continue, can I confirm that the screen in focus now is my collab notebook?
Yes, sir.
Yes,
Yes,
it is.
yes, which is we can see you.
Yes.
All right, thank you. Okay, so this is the same notebook. Um that this notebook will actually be shared after the course of the live coding session. So what we are trying to do is, when the live coding session is done, the notebook and the slides will be shared to everyone. But if I think there's a lot of clamor for the notebooks to be shared at this point in time, so probably after this live coding session, we can just make it available at the current point where it is. But the main idea is we'll share these resources after the conclusion of the live coding section. So we'll just be continuing with the same notebook, and you can see that these are all of the codes that we used for NumPy here. So let me just clear all of these outputs. Let me clear all of these outputs so we can take it from a fresh start. Series analysis, sampling. Okay, so I need to connect to a new one time. We clear this. Exactly. So the first thing we'll be doing is we'll be creating a series. So as usual, the first thing you do when you want to work with any module that is not provided directly by Python, you have to import the module. So we are going to use the import statement to import pandas.
Hello, sir.
But the-
Sorry to
sorry.
interrupt. Please, could you like zoom in like you did the last time?
Oh, sure. I think this is fine.
Yes, it's better. Thank you very much, sir.
Yeah, no problem. So
Ah,
the
Hello, sir.
hello. Hello. Can you guys hear me? I thought someone was about to say something.
Yes, we can hear you, Ade.
All right, thank you. Okay, um so the first thing we'll be doing, let me just take this a bit lesser. Exactly, I think this works too. So we'll be creating a panda series. So let me just run this code, and you can see that this is a panda series. So a panda series is the equivalent of a numpy 1D array. If I come here, let me just create another code block here and say what is the type of the series that we just created. You see that this is a panda.code.series, and this is a one-dimensional blah blah blah. This is just collab trying to provide some more information about this data type and what it does. Then I want to show you how this is integrated with numpy. If I perform this now and do something like this series dot values, you can see that this automatically is an array. If I okay, let me just complete this and say what is the type of this. You can see that the type of the values in this series is a numpy nd array. So a numpy array is what powers most of the values that you see in a pandas data frame. So you can see that each row in a pandas data frame corresponds to one array that contains all of the rows. Then each column also corresponds to one numpy nd array that contains all of the columns. So this is a series, and is one of the least data type for pandas that you will use, because most times you use data frame, it is very odd for you to want to work on a data and you are only working with one column. You cannot at any point in time be confident about the nature of the results you get when you are working with just one column. The scenarios where you work with a one column data set most times in the time series data, in the sense that most time series data, or should I say that a perfect time series data is a data where you have just the index, which is the index serves as the date and time, and then you have the values, which is what probably you are trying to predict for, or what you are trying to analyze. So most times, even if you are given a data set that is a time series data and it has a lot of columns where you perform a lot of analysis, check some trends that have happened over time and what have you, in the end you are trying to probably predict for one particular column, and it is that column that you'll be used to train. So it is good to know what a panda series is and what it does, but it is one of the least data type that you use. So the actual data type that you use is called data frame. And you can see a pandas series is created from a list. But to create a data frame works the way a data frame works is that a data frame works as a table. So every table is going to have each column that each value is going to belong to. So that's why when we are creating a pandas data frame, we use what? Dictionaries. So in dictionaries in Python are key value pairs. This is popular knowledge. So each key serves as the what? As the column name, and then every value that is put in a list for the value corresponding to that key is going to serve as the column. So you can see that in this dictionary now we have one column. So this is a column called name. In this we have three rows. The first row is Alice, the second row is Bob, the third row is Charlie. Then we have another column called age. In this row, the first age is 25, the second age is 30, and the third is 35. And then we have the same. So if I do this now and run this cell, you can see that this is a tabular data where this is the column name, this is the second column's name, and this is the third column's name. And then for each row, so you can see that you can start to visualize each row as the what? As the list. So Alice, Bob, and Charlie, sorry, each column. But for each row just says that okay, each value Alice, 25, and New York. So if I take this data frame that we just created now, df, and I also do something called dot values, just as I did the last time, you will see that this is also a numpy nd array. And in this nd array, just like we spoke on the last time, if I do dot shape, I can see the what? The shape of this array. So the shape of this array is an array that has a shape what? 3 by 3. So if I say enter, this will work particularly. So what now happens to show you one of the ways that pandas is giving us a functionality? Let me try and remove a value from this. I don't, if you can recall the last time, we tried to create one array that did not follow the format, in the sense that we made a particular list. When we were creating that array, we made that list lesser than the number of items in that list lesser than the number of items in every other list, and it gave us an error that it is not following the rule of homogeneity that is associated with numpy arrays. So in this data frame that we're trying to create now, we have reduced the age from the number of items in the age list. We have reduced it from 2 to 3. So let us see if this will get created or not. we can see this also give us that all arrays must be of the same length. So this is also giving us that error. But over time, I would show you a way, in a sense, where this will be possible by using something called NaN values. So let me just fill this with another value 40 and then run this again, and you can see that this has worked as expected. So each of the values in this df are what are arrays, and you can see that if I this is a 3 by 3 array, so if I index the first row at least 25, this is also an MP, this is also a numpy array. If I index the second row, this is also a what, a numpy array. But the way you can get all the values of a column in a pandas array is by saying there are two ways you can do it. The first way is to write out the name of the pandas data frame. You can see we name the data frame df. That's why I'm using df. So you can write the name of the data frame and then use this curly bracket. So curly brackets are what we use when we are creating lists. So the kind of bracket we use when we are creating lists, and then we'll write the name of the column we want. So let's say I want to get the name column. You see that this is giving me a what, all of the values that are in the name column: Alice, Bob, and Charlie. Alice, Bob, and Charlie. But you can see that this is not a numpy array. So it is only when you are accessing each row that you get a numpy array. If you access each values in the column at once, what you get is a pandas series. So if I do type and I do this, you can see that the type is a what, a pandas series. So with this, you can say that okay, every row in a pandas data frame is contained as what, numpy arrays, but every column singly is known as a what, a pandas series. So this is one of what pandas series is doing. So the point at which you have to work with pandas series is when you are trying to perform an action on a row, or sorry, on values in the column on its own. So when you are trying to perform this action, you will need to know the functionalities that the PD series gives to you. But most of these functionalities are the same even for the data frame. So to get that's the first way to get a value. Another way that you can do is you can use the dot operator. So when I say dots and I say name, you see that this will also give me the same value. And these are the two ways that you can access what, the values of a particular column in a data frame. So you can do this. So if I do this for age also, age, and I press Control and enter, you see that I've gotten all of the age that are in this column: 25, 30, and 40. So that's the easiest way to create data frames from the scratch. But most times in practical scenarios, in practical real world applications, you most likely would never have to create a data frame from the scratch like this. Or even if you have to, it is going to be as a result of actions that you have first performed from a file that is provided to you. So we have a popular file type that you are going to be working with. You must have seen it. For those that have taken the quiz, you'd have seen this file type. For those that are following the code snippets to the letter, you'd have noticed this file type also. It's called a CSV file type. So CSV stands for comma separated values. You can see that here it is being shown as a table. So CSV is one of the most is one of the most widely used is one of the most widely used file type to show tabular data, and that is why pandas has a lot of functionality. So most data sets that you have to work with in practical scenarios will make use of a CSV file, which will contain all of the data that you need. And this is also how you can read in incomplete values into a data frame that does not follow the same structure. Sorry, can you guys hear me? Think
Yes, Ade, we can hear you.
okay, thank you. So because my own time disconnected, so I just wanted to confirm. So as I stated previously, comma separated values. So these are CSV files, and they'll probably be the files that you interface with most of the times. Let me say 80% of the times as you work more on learning how to um, create data science solutions. So I want to try and show you this file without it in a I want to show you these comma separated files without it being in a tabular format. So you see that every value there is being created with a comma. Let me try and download this first and then open it with if Google will allow me open it. Okay, it is not coming up. No, it's not coming up. So let me just, I will not waste our time. Probably over time you see this, or I could send a screenshot or probably share the file to you guys on the group. So you see how comma separated value files are. In the raw format, basically every row and every column is separated with a comma. Let me just, I would like to show this rather than keep that till later. So let me just try and um let me try and do that now. Sorry. So this will be under documents, data.csv. Exactly. With node plus plus plus. Okay. Um so I've switched the screen I'm sharing. Can you guys see a new screen? So this is the comma separated file without being formatted in a tabular format. So you can see each row is just each row is just separated by a comma. So you can see the first row is name, age, city, salary, education, and date. All of them submitted by commas. Then when you move to the next row, so the first name that we're talking about is Alice. Then the age of Alice after a comma is 25. Separated by a comma is New York. Separated by a comma, salary is 5,000, like that. And this is repeated up till we get to number 17. But if you see this, for example, this row 12, you can see that we have just Kevin, his age, the city he's in, his salary, his gender, his education, and his age. Okay, this is also complete. I'm trying to look for a row that is not complete. Okay, yes, yeah, you can see row 7 for Frank. Frank name is there, but he does not have an age in this data set. So this is Frank's age. Age is gone, and is though he stays in Boston, 9,000 male PhD, but the age is not there. So in row 7, you will see that this data is not complete, but it will still get created as a pandas data frame, because when you use file storage, pandas automatically knows how to convert non-existent data. It automatically converts it into null values in the data. So in the backend, that is what a comma separated value file looks like. And over time, you still see more of these comma separated value files. Okay. So something in the chat is just saying yes, comma separated value files is Excel. Excel also identifies this file. So if you open a CSV file with Excel, it automatically opens it up as though it were an Excel file. It's open it up in a tabular file. But the CSV file in its raw format are just files that are separated by a comma most times. Over time, you start to learn that it might not be only a comma that you might use to separate. There's a new file type also now that is called TSV. So in TSV file, rather than separating each value by a comma, you separate it by a tag. But over time, as you begin to work with more data, you start to gain more experience with things like this. So I will read in the data now. So let me read in this data. Now I'm reading this as a, so to read in a data as a CSV, you need to use this command pd, which is pandas dot read CSV, and then you put in the file name. If it's possible that where the file is located is different from where your notebook is located, you might have to find do to put a file path. Let me try and show you what I'm trying to say. So let me create a new folder here. I'll call this folder sample. Okay, so I'll move this file here. Let me see. Is there a way I can move this file? Yes. So I've moved this file into sample file. So if I um if I try to run this code again, it will give me an error. So there is no such file or director data.csv because previously the data.csv was in this folder here, and this folder here is where Collab automatically stores your notebook that you're working on. So because I have created a new folder called sample, and that is where my data set is, data.csv is not existing in this folder here where my code is being stored. So now I have to provide here and come and say, okay, you first need to look into a folder called sample, then you provide a slash to show that it is a folder, and then inside that folder you find data.csv. So there's a typo here, sample. And then if I run this code here, you would see that the file has been read in successfully because if I was reading successfully because now I've specified the actual parts that this file is existing in, and that is where you should go and look for this file to read it in. So when you are trying to read a file, you should also understand file parts, so you'll be able to direct your Pandas library to the correct part where your file is stored. So you can see now, the you can see this is David salary is not in this data set. You can, when it was in comma separated values, it was not easy to spot, but because of now Pandas has shown this as a tabular data, it's easy to spot that okay, for this particular row there is a missing value. So this is how you read in data with CSV using pd.readcsv function. And then we'll be moving on to the next thing, that's data manipulation. So data manipulation is a lot of different things that you can just use to access data. So you can see the first thing I did previously, I showed you how to access one single column from a data set. But if you want to access more than one column at the same time, you need to provide each column that you want to access as a what? As a list. You can see here now, still selected underscore columns. So yeah, if I just accidentally remove this extra curly bracket here, you remember that when for okay, let me just do it from one first. So for age, if I do this now, you see that all of the names have been selected. Cool. If I now say I want to select not just the age, I want to select the age also, this will return an error because for you to access more than one column from a pandas data frame, you need to provide these columns as a list. So now I have to put in another curly bracket here. So the inner list here is where I can now start specifying the names of the columns I want to access. So if I run this now, I will get the two selected columns, which are the names and age. So I can change this from age, I can change this to salary, and I will still get the value. Or I can even decide to add age, and then this will give me the name, the salary, and the age. This is also a very useful way when you want to rearrange column names. So let's say you want to rearrange column names in another order. You just provide the column names you want in the order that you want it to appear, and then the new data frame you have will contain those column names that way. But if you try to access a value that is not in the data frame, let's say I'm trying to say ages, you return an error that will tell you that ages could not be found. Ages is not in the index. So when it was going through all of the columns, it did not find something called ages. So there's an error. So you have to fix the errors. And that's how you can select multiple um multiple columns at once from a data frame. So another very useful functionality, and this is something that will be expanded more in the next stage for most of you guys, is how to filter what is being returned. So before I do this, let me just show you the old data set. Let me say df.ed. So df.ed is how you get the first 5 items in a pandas data frame. So to get the first 5 items, when you say df.ed, you can see that it gives you 0, 1, 2, 3, 4. These are the first 5 items. But if you want more than the first 5, you can specify a number here, and this will give you the amount of numbers that you specified in the item. So now I've said that okay, I don't want the first 5. When you do df.ed, give me the first 10. So if I run this, you'll see that okay, this is the first time. You can remember that in number, where did we have someone without a age? I think it's number 5. Yes, you can see for Frank now, his age is not there. He has none. We have all the other details, but his age is not present. For Gabriel, every other details are present, but our ages and our education level is not in the data frame. So this is how we can do this. So one thing that we can do now, let's say um I just want to return the values that are what? That are the values of people where their age is greater than 30. That is what this condition here is doing. So now, if I say, okay, in this data set, let me just show you the data first before I then go through the syntax. So this is filtered underscore data dot head, and I run this. You see now that it is returning just 1, 2, 3, 4, 5. Or let me even try to return 10. This is 1, 2, 3, 4, 5, 6, 7, 8. This is not up to 10. So when you do data df.head, any data frame dot head, and you specify a number and the total data frame is not up to that number, it just automatically returns the old data frame to you. So you can note that. You can see now that every age in this data frame is greater than 30. This age is 35, 35, 31. There is no age here that is lesser than 30, even though in the original data frame you can see that Alice had an age of 25. Isaac had an age of 25. Jessica was 28 years old. But all of this has been excluded because you have specified that you should only return this data frame when the age. So we use the syntax to access a particular column and then say that when this age is greater than 30, return this value. Just like to show you how this is working in the back end, let me just do this. Df and the age greater than 30. What you see is a list of true or false values. So when you have false, it tells you that okay, at this particular row, this condition was not met. So in the first row, the condition that the age value there should be greater than 30 was not met. In the second row, the condition was not met. But in the third row, the condition was met, here it was met, here it was met, here it was not met, and so on. So when you do this at first, you get a boolean that you know that okay, these are the false values and these are true. So when you now enclose all of this into curly bracket and then use this to index the data frame, then the data frame will just look at the values that have the rows that have a value of true and just return these values. So that's what is going on at the back end. So the pandas looks at the data frame or the index you are providing and sees the values that are true. So when it sees the values that are true, it is just those values that is going to be that is going to be returned. um Before going on to the next stuff, I also want to show you how to access a particular row from a data. There are two ways that you can access rows from data, but the correct one and the best one is to use the iloc. So when you do an iloc, you provide the index that you want to access. Okay, don't let me use this iloc 0. So you can see when you say iloc, I here means index, then LOC means location. So index location at what? At 0. So if you go to the actual data frame, not the filtered one now, you can see that everything at 0 is what? Alice with an age of 25. She stays in New York City with a salary. She's a female, bachelor's and stuff. And you can see that that is what we have here. Alice, her age is 25, New York City, female, bachelor's, and that's the date. So this is how you get the whole of the values that is present in a particular DM. So if you try to check the type of um this will be returned as a series data. Enter. So this is a series data. So when you try to access just a particular value from the row, just only one row, what you have is what? A series data that contains each and every value that is contained in that row. So that's how you access the element at a particular index. So you can access elements and get all of the rows. You can access element and get all of the columns, and you can also access element to get one particular column and one particular row. Another way of accessing data, so let's say for example I don't want to return every value here, I just want to return the name of this person. So instead of providing just the name, start point, end point is not included, okay, instead of providing just the name, I will come here and instead of providing everything, I will just come here and include the name. So you can see, so when I first get the iLock, okay, for the value that is at index 0, give me just the name of that value. So instead of it to return everything, it's just going to give me Alice, which is the name at that point. So if it is her age I was interested in, I will say that give me her age, and it will give me the value that is her age. So that's another way of accessing elements in a data frame. So you can perform different kind of filtering. So let us try and perform another filter. Let us say, okay, um give me, let me clean all of this so I won't have to be saving too many times. So let me say that give me something where the salary is lesser than or equals to 7,000. Okay, let me use 70,000 because the values are big. You can see that from the data frame that we have, just three people are earning lesser or equals to 7,000. The first is Charlie, sorry, the first is Alice earning 50, then Bob earns 60, then Charlie earns what, 70. And we can see that from the education, one has a bachelor's, the least person with a salary has a bachelor's degree, the other person has master's and PhD. So these are ways where we start to like draw insight from data. So a sample question that could be asked is, okay, check how the education of a particular person correlates with the salary that they are receiving. So is it that there are more people with bachelor's degree that earn lesser? So are we saying that as their qualification increase, then the amount of salary they earn increase? So these are the kind of questions that we'll come up with in our next live coding sessions, where we'll try to use pandas and matplotlib to try and create visualizations that we use to answer real world insights that we can gain from our data. So this one, so this is another quick filtering that we just did to just get values of salary that is less than 7,000. Okay, so another thing we can do is called aggregation and grouping. So with pandas, you can automatically group data, in the sense that you might have data sets that contains, okay, let me just show you. For example now, um for example, let me just do this, let me run this group data. So what this code here is trying to tell us is that we want to group this data here by the city. So it's possible that we have some people that are living in the same city. So instead of having each city coming up separately in the data set, just like you see here, New York is here, then New York is here again. New York occurs at index 0, and at index what, at index 6. So rather than having a data frame where each person from New York is shown separately, what if we try and see the data just from the perspective of New York? So yeah, what we are trying to say is that in the city, for every city, get the what, the mean of the age. So I can just do this now. If I show you group data, if I show you what group data is, you can see that in group data now, all we have are the what, are the different cities that are existing in the data set, and the mean age of people that live in that city. So the mean age of people in New York, their mean age is 30, while the mean age of people in San Francisco is 34, while those in Boston have a mean age of 38, those in Chicago have around 29 years of age. So this is the way you can start grouping data to see things that are common to different what people. What if I don't group by the data now? What if I try to group by the gender? So I can come here and change this to gender, and say that rather than just the age and the mean, give me also the salary and the mean also. So if I check what group data is now, you see that now it is not giving me by city, it's giving me by the gender. And we can see that the mean age of men in this data set is 32.5, and the mean age of the females is exactly on 32, while the mean salary of female is 12,000 121,000, sorry, 250, while the mean age of men is 118,500. So if this data was for a data in a company, for example, with this data we can say that based on the data we have, we can see that on average the females are earning what more salary than the male are doing, because when we try to take a ratio of each men, so what you understand what the mean is. The mean is the average, so that's the total salaries of men divided by the numbers of men in a company, while for the ladies is also the same. So you can see that on average, ladies, it's possible that there are some men that will earn than some ladies, and there will be some ladies that will earn than some men, definitely. But on average, the female, what they earn higher salary than the men. That's the insight that has been drawn from this data just by performing this action. So we can start to group data by different columns and try to see insights that are containing to different classes or different labels that are existing in that group, and we can visualize some of this data. So it's not only this way that you can use to, instead of using this .agg, this is the official method by Pandas, but you can also do something like .sum. So if you do the .sum and you don't specify the column, what is going to happen is that it will try and sum every single column that it can. So you can see now that you are not specifying any column, so it is trying, even name for the name is trying. Okay, sorry, can you guys hear me now?
Yes, we can.
Yes. Okay. So what is trying to do here, because you have not specified any particular column you want to sum, it is trying to sum every column together. So for every person that occurs, so for every female, their names, it is just summing their names together, it is summing their age together, blah 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 and stuff like that. So you can specify what columns it should actually sum by providing that here. So I can say, okay, I want you to sum the age and the what and the salary. So when you do this now and you check what group data is going to contain, so you can see that group data is containing just the what, the age and the salary, and it is the sum. So you can see that the female salary, the sum of the female salary is higher than the sum of the what, than the sum of the male salary. So these are different kind of insight that you can pull from data. So for handling missing data, to handle missing data, um the first thing that you should know is that Pandas provides you with a way to check some key statistics or some details of the data. So one of the first one that I will show you is df.info. So anytime you read in a new data set, um it is always prescribed, or it is always advised that you do three major things. Number one, you want df.info, you want df dot describe, then the last one, df dot is now dot sum. So these are the three functions that most times you always want to try and perform firstly. Immediately after you reading any data set, you just want to perform this function so you can get an overview of what your data contains. So what df.info gives you is, it gives you the name of each column, it gives you the name of each column, it gives you the number of what, of null values, or the number of the non-null in a way. So you can see here that it is saying that in this particular column there are 16 non-null values. So the range of the index tells you the number of observations you have, the number of rows. So the number of rows we have are 16 based on this here, this value, and it goes from 0 to 15. So when we have 16 non-null values, it tells us that okay, in this column there is no null value basically. The age says that there is 15 non-null. So what we can say from this is that okay, for the host column there is one column, sorry, there is one row where the age of that person is not what's given. Here too, the salary, we can see that there is one column where the salary of that person is not given. So that's what df.info do. Then the next thing is df.describe. Df.describe give you a summary statistics, and it works only for the numerical values in the column. So when you do df.describe, it will first go into the column and check for the columns that have what numeric data type. um and how do you know the columns that have numeric data type? That's the last thing that df.info shows us, d type. So when your d type is float or integer, it means that you can be used directly for calculation. It is already in an integer format, it is already a number, or it is already a decimal point, it is already something that can be used for calculation. But if it is an object, then it means that the format that it's in is either a string or something that Python does not understand. So you can only do things that you would do to a string, but you cannot try to add those values together or try to multiply them together, because they are not what? They are not integers. You cannot work with them. So when you do df.retrieve, it first selects the columns that are numeric, and here we have just two, age and salary. And then it provides the first thing, that's the count. That means the number of observations you have. So the count, if the count is the same as the number of rows, that means there's no null value. But if the count is lesser than the number of rows, it means that there are no values in the what? In the data frame. Then you also have the what? The mean. So for all the for all the ages we have in this data, this is the mean age. For all the salaries we have, this is the mean salary. This is the standard deviation. This is the what? The minimum age. So there's no age in this data set that is less than 25. So based on this now, you cannot even, if you have done the describe from the beginning now, you can know that okay, from this data set, we have nobody here that is lesser than 25. Everybody is from 25 upward. And we also see that okay, for the salary, nobody earns less than 50,000. So imagine when I was writing this query earlier, this query now, I had said lesser than 50,000. I would have gotten an empty dictionary or an empty data frame, because there's no one here that learns less than 50,000. So instead of you to start writing all of these queries without knowing, df.describe will help you to know all of this information. So there will be some data that you write, that sorry, some queries and insights that you try to do that you avoid, because you have seen it from the statistics. Then you also have the 25%. So this from the minimum to 25%. Then these are the average values, the 50% of people, the values that they fall into. Then 75% of the observation, they fall into this range. And then the maximum value. So the maximum age in this data is 45. Nobody is older than 45. And the maximum salary is 190,000. Nobody earns above this value. That's what the described does. And then the last thing is any dot is sum. So what this does, it sums up all the null values that each column has. So it looks into each column. If I remove this dot is sum here, it will just give you a lot of true or false. So for each column, you go, is this a null value? False. Is this a null value? False. Blah blah blah. So when it comes here, is this a null value? True. It writes here that okay, this is true, this is a null value. So instead of it having to do this manually, just one dot sum. So this is also a way of aggregating data. So when you want dot sum and you do control and enter, so it just sums up all of the true values as one and sums up all of the false values as zero. So any data, so for example, you can see here now that we have confirmed that okay, in the age column, there is what? One null value. In the salary column, there's one null value. In the education column also, there's also one null value. So these are the three things that I recommended that you do as to get a summary statistics anytime you even know the data from the beginning, so that you know some steps that you don't have to take because you have gotten all of this information. So we have come to the ending of the live coding session for today. Next live coding session, we will start with time series analysis first, and then we will work on a larger data set where we will try to use pandas and matplotlib. So we'll also introduce what matplotlib is, and then we'll try to use pandas and matplotlib to try and answer some questions and create some visualizations. Okay, so um, if there are no other questions, as usual, the stage ends on the 16th. So try and ensure that you have gone through every course content and you have submitted all your deliverables before the closing of the stage on by April 16th. And the track selection form It's closing very soon. I think that is April 9. So kindly check the pinned information, the onboarding emails for up to date announcements so you don't miss anything and you don't get left out. For any of your questions or queries that you have, just direct them via Slack in the Ask Amoye channel, or you can send a mail to help@amoye.org. And with that, bye bye for now. See you guys later in the week.